mistake. Let me summarize 4 typical mistakes they did not do well. This one you don't have it, you need to take notes. Write it down. Most of you did this correctly, but a couple of you did not do it right. In doing your heat integration, your assignment, exam problem, first you pay attention to heater cooler location. After pinch analysis, whether QH mean, QC mean, if a problem doesn't require cooling utility, then there's no cooler. So that's after your pinch analysis. Where do you put your heater cooler? This is your assignment 1. A couple of you did not do it right. This one is done correctly. In a typical problem, steam temperature is the highest temperature hot stream. So, above the pinch, on the high temperature portion of hot stream, you match highest temperature hot stream, steam, with high temperature portion of cold stream. The goal is the average block temperature. This is the highest heater block average temperature. Now, for this, we did this problem in your assignment today. The second problem, I give you a solution. You need heater.
It's out of focus, Dr. Liu.
What, Jeff?
It's out of focus.
Oh, sorry. Better?
Better.
Thank you. Now, for this problem, the second problem, we know the minimum heating requirement. Where do you put your heater? That's where you made a mistake. Again, steam temperature the highest. You have 3 different options. It really depends on capacity, flow rate. You want to put a heater giving the highest heater block temperature. For the same heat duty, you put that in this block, in that block. Those average temperature is lower than this. So, always match highest temperatures external steam with highest temperature portion of cold stream, giving you the highest average block temperature. That is your second problem. to problem 1. Cooler temperature should be here. In assignment returned to you. And remember, you put that heater on this block. That's not correct. Why? You look at cooling water temperature given the problem, cooling water, CW. That is the lowest temperature among all cold streams. So, you want to match cooler to the lowest temperature cold stream. You put cooler here, wrong. Okay? That is your first mistake in doing problem. Pay attention to it. Second, block heat duty and intermediate temperature. So we can check stream matching and delta T mean violation. This is the second mistake you could make in the exam if you don't not pay attention to it. What do I mean? You must find out intermediate temperature for each block. So we can check the heat duty. The other thing is, in the return assignment, many of you got caught. Why? I need to check, for example, E3, 220, 218.73, that delta T is greater than delta T mean. I need the intermediate temperature to check. For example, E2, 353, 220, and this delta T. You need to check both high temperature side and low temperature side. Make sure delta T is greater than delta T mean. In your submitted assignment, many of you did not do this. That's causing mistake. The third thing is you need to check average block temperature ranking on both hot and cold side. I have this in a solution attached to your return homework. What do we mean by this? E1, that's the highest temperature, number 1. Here, E1, number 1. E2, E3. You see, the idea is highest temperature hot stream exchanging heat with highest temperature cold stream, intermediate temperature portion of hot stream exchanging heat with intermediate temperature portion of cold stream, lowest temperature portion of hot stream changing heat with lowest temperature portion of cold stream. You check the average block temperature in the ranking on both hot and cold side. Should be consistent for a large problem, five-stream problem or six-stream problem. This ranking, you may have one out of order, that's okay. So you need to check all this. Any question? Pay attention to this. The second thing I want to do today, I give you a practice problem given on Friday. And there's a problem and solution here. Let me explain to you now. I will do this practice problem today. On Wednesday, please bring your Aspen. I will give out your final project assignment, number 1. Number 2, if you do not have any change in the project partner, still the same 2-person, you do not need to let me know anything. If you change your partner, you better be careful. You might affect the other teams. So both teams need to negotiate, agree upon it, okay? And there's one student, one single student, but do not worry about him. He has done homework very well. He can handle it, okay? Now, for your final project, focus on Aspen column simulation and heat integration, okay? Now, because university takes away too many on Friday, this is a very unusual year. We cannot do safety analysis and final economic evaluation of this project until the first 3 weeks of next semester. This semester focus on correct Aspen simulation of both column and heat integration and utility cost saving. You did assignment 1, you know how to calculate it. Okay? I will explain that on Wednesday. Now, let's do the problem 1. In the new handout, you need to practice doing this correctly. So, I might add 4. Practice doing pinch analysis correctly to find correct QH mean, QC mean. If this step is not correct, step 1 will be in trouble. Step 2, step 3, all will be in trouble. So you need to know how to do this correctly for your exam. Now for your exam, I give you a table. You can fill in a number, but for your problem 2, you have QH mean, QC mean. Some of you did not do this correctly. Make sure you take time to study my solution attached to homework. Find out where you made mistake. Now, form 3, I got about only 60 students turning in the solution. If any of you did not do it, you did not get solution, if I did not send to the class the solution, you need to contact me, I can email you one. Now, for this problem, 1245.9, QC me. Let's look at this problem. How do we create this network? Okay? So, a minima above the teach. This is your handout today. For this problem, no steam required, only cooling water. You have 3 hot streams, 4 cold streams. No need for heating utility, only cooling utility, -1. 7. Could be 6 exchanger, 1 cooler, or 5 exchanger, 2 cooler. There's no peach, sorry. Cross that out. There's no peach. This is the whole problem. So now, let's start. First thing you need to find out total heat duty this is your step 1. Finding out all the utility requirements. Step 2. You find out for the whole block, I mean the whole big block, okay? And you know it's obvious that's the high temperature hot stream, right? U1. You come down, you see here, 119.4 average, 148.9, 129.5, 129.4, 132.2, 146, and I think 209. Before matching, what is the temperature ranking of different blocks? You know 193.4, this is the high temperature cold stream. So, I found out block temperature, step 2. Find the average block temperature. Step 3. You go from high temperature down, ICH2, ICE1. So, E1, 331, 247.7. E1, right? That is my first exchanger. The next one, ICE2. Okay? On the cold side, C1. So, H1. C3. Step 5, step 5. And then come down H3. C2. Step 6. Oh no. Yeah, 6. Okay, now keep going down. E5. E5. 7. 7. So, what's remaining? 2 blocks. We have put in fire exchanger. We can put in 2 more cooler. 1, 2. Area. Some. Wonderful. That is QC me. Now, the way we did this, highest temperature downward, right? So, in terms of average block temperature, on hot side, cold side, perfect. You look at this, perfect. Now, you do that, ignore the importance of delta T mean. Let's check. 271.1, 221. That's more than 10 degrees. 244.7, 79. Oh, E1. Let's look at E1. E1. 271.1, 210. 244, 177. Good. All right? So, do not forget the step. Checking the high temperature side, checking the low temperature side of each matching. What you did not do in problem 3 and causing some trouble. All right? This is straightforward. So, let me repeat. What are the things you need to pay attention to? 1, heater, cooler location. Cooler, typically in the low temperature portion of hospital. 2, block duty and intermediate temperature. Delta T mean. Three, average block temperature ranking on both hot and cold side. Right? Of course, doing pinch targeting correctly. That number must be correct. QC mean. Any question? I will give you more practice problem next week, maybe next Monday. Okay, not this week. Okay. The back of this page. So, how do you look at this problem and mean? You have 3 hot stream, 1 cold stream, only heating utility, no cooling utility, full. This problem N has 7. How do you improve it? Remember I talked about loop breaking. To simplify this problem, where is the tricks? Let's go through this problem. Here, there's only 1 cold stream, C1. You have 3 hot streams. Now, C1, it does not make sense to exchange heat with the same hot stream twice through 2 exchangers. One cold stream, 1 hot stream, 1 cold stream. It doesn't make sense to buy 2 exchangers, right? So, what's the heat duty? You add them up, 2268. I call this merging these 2 exchangers. E1 prime. We do the same thing. H2. That is exchanger E2, E4. Exchanger 2, right? This is a small loop. You add them up, that is the second one. And then here's the third one. So, we have the heat duty of the 3 branches. And before entering the heater, mixing temperature 206. 206. So, we need to find out 6 unknown. Total capacity flow rate, MCP1, MCP2, MCP3, plus 3 temperature. So, let's write down first total heat capacity flow rate right here. We are going to split this sum of the 3 equals 36.93. Mixing temperature, the way you do it, total heat duty divided by capacity flow rate, MCP1, T1, MCP T2. This is the weighted average. So now we have 6 variables. This should be 3. I can only write down 5 equations. My question to you is, what assumption you are going to make next? What do you do next? In order to find T1, T2, T3 capacity flow rate, MCP1, 2, 3. Help. I need some, yeah.
To find MCP 1, 2, and 3, you can take a ratio of the heat duties, like from split 1 to the total, and multiply it by the heat capacity of cold stream 1.
I don't know if that may work, but it's not the simple one. Okay? What's the simple one?
Average.
If I give you this problem, say I give you delta T mean, 10 degrees C, okay? What does delta T mean mean? 260, right? T1, exchange 1 on this side. That's delta T. Okay? Delta T should be
10. Or more.
or more. That's the key, or more. What do you do about T1? Above how many degrees? I need one assumption to solve 6 equations, right? For 6 variables. I have 5 equations to solve 6 variables. I must assume the value of one variable. You said more or more, that's the key to your assumption. Anyone? You can pick a lot of value of T1 as long as 260 minus T1. So if I can take 240, then delta T is 20, right? That's greater than delta T mean, right? You assume there's 240. You put in 240. Now, 5 variable, 5 equation. Can you do it? So the answer is be practical and flexible, okay? That's the trick. Any question? Now, let me see. Last 10 minutes. I got many questions about minor project. To explain the first 3 parts, do not use your imagination. Think about this and that. You should use the result from your simulation. Where? Stream table. Where you see the composition, flow rate. You should go to your column and the profile. You find out on each trade what happened to carbon 2, more flow rate, carbon 3, more flow rate, 3 temperature. A student gave me a long explanation about what happened to carbon part 1. I said that's highly qualitative. You don't do like that in this problem. You need to be quantitative. What do I mean? Set up some table from your stream result. Why does change temperature, what happened to it? The top temperature. That's what I mean by quantitative. Backed up by number from your simulation. Use those to explain. Don't give you any qualitative explanation. That doesn't count. Do you get it? Pay attention to stream result table and profile table. What's the question?
Are we explaining why all of carbon 3 is vapor?
Why you do not get the correct answer, number one, when you change the condition of part 1, 2, 3, why are you getting better? Are you clear? Be quantitative. That's almost done for 3 part. Okay, it's your job. I have several students show me the answer, part 4A, 4B, easy. Okay? Now, where can you change in part 4? Are you paying attention, writing that down again? I don't have money for you to buy condenser. No money to buy heater, cooler. You have 3 side exchanger across stage 2, 3, 4. You don't physically move them, but you can change the heat duty from positive to 0 to negative. 0 means you don't use it. Now, for this problem, you cannot change number of stages. Column is fixed. Pressure is fixed. Okay? You're given the top temperature, bottom temperature. If you get good correct simulation, your temperature profile will match it. You may change. You cannot change your temperature, pressure, flow rate of V feet, L feet, vapor feet, liquid feet. It's given from upstream. Your boss asks you to process them. You cannot change it. Your needed oil is an external solvent. You buy from your customer, temperature, pressure, given. You cannot change it. If you want to change, that means you need to buy external heater, cooler. I don't have money. You want to buy less, lean oil flow rate, all power to you. I don't have money. You save me money. You want to use more, I don't have money to pay you, right? You want to buy less external solvent, you save my money, you get bonus. Can you change solvent fee location? That's what you need to try. All right, that's all. No more. Okay,